Hi, sixth grade. Um, let's see, I'm gonna try to get that. Okay. Welcome to this week, another week of distance learning. I hope you had a great weekend and you're ready for this week. For this week and the coming weeks, we are going to try some video lessons along with PowerPoint presentations, just to help you feel more connected to the math class and to me. That'll be great. So this is what we're going to try out, and hopefully once I get the hang of it, the videos will become better and better. But for now, please just accept what you see and let's just try our best. Okay, so I'm gonna start the slideshow. Let's see, play from start. Okay. Um, all right, I'm really excited to see you. I thought this Pikachu was super cute. That's how I really feel on the inside. So today we're going to continue to review Chapter 9, the coordinate plane. I'm sorry that my face is blocking the title there. And we're going to watch a video to recall the basic facts about the coordinate plane. And I think you recognize this man, I have to point this way, huh? This man, we've watched his videos before. I really enjoy the way that he breaks down math concepts. And I think it's great to learn from other types of teachers because that way, you know, we have a better chance of grasping the concept because the way I explain it might be different from the way another teacher explains it. But anyways, enjoy. I'll start playing it for you. I'm gonna cover my
Hi, I'm
face.
Rob. Welcome to Math Antics. In this lesson, we're going to learn something that's an important foundation for tons of math problems, including those you'll encounter while learning basic algebra. We're going to learn about graphing, which basically means taking mathematical relationships and turning them into pictures. Hey friends, welcome back to the joy of graphing. We're going to pick up right where we left off. We already have this nice, beautiful function right here, but it needs a friend. And we're going to do that by adding some points. So let's put the next point right here. Now all we need to do is connect those points. Because they're all friends. And what do friends do? They stay connected. Oh, look at that. That's beautiful. Well, not the kind of picture that you'd hang on your wall. Graphing just means making a visual representation of an equation or data set so you can understand it better. It's a way of helping you literally see how math works. When math is just a bunch of numbers and symbols on a page, it can be pretty abstract and hard to relate to. But graphing is like a window into the abstract world of math that helps us see it more clearly. In fact, the focus of our lesson today actually looks a bit like a window, and it's called the coordinate plane. The coordinate plane is the platform or stage that our graphing will take place on. But to understand how it works, we first need to start with its closest relative, the number line. You remember how a number line works, right? A number line starts at 0 and represents positive numbers as you move to the right and negative numbers as you move to the left. And there's usually marks showing where each integer is along the way. Now imagine cloning that number line and rotating the copy counterclockwise by 90 degrees so that the second number line is perpendicular to the first, and they intersect at their 0 points. What we have now is a number plane. It's basically like a two-dimensional version of a number line, but that second dimension makes it much more useful. With a simple one-dimensional number line, we could show where various numbers were located along that line by drawing or plotting points. But no matter how many points we plot, they're always on the same line. But with the two-dimensional number plane, we can plot points anywhere in that 2D area, and that opens up a whole new world of possibilities. With the one-dimensional number line, plotting points was easy. You just needed one number to tell you where to plot a point. But with the two-dimensional number plane, you actually need two numbers to plot each point. These two numbers are called coordinates because they're the same rank or order, and they work together to specify the location of a point on the number plane. In fact, that's why the number plane is often referred to as the coordinate plane. It's the stage for plotting coordinates. Coordinates use a special format to help you recognize them. The two numbers are put inside parentheses with a comma between them as a separator. So when you see 2, 5, or -7, 3, or 0, 1.5, you know you're dealing with coordinates. Okay, to understand how coordinates work, remember that our number plane is formed by combining two perpendicular number lines. From now on, we're going to refer to each one of these number lines as an axis. One of the axes is horizontal, like the horizon, which means the other axis is vertical, or straight up and down. And they're often called the horizontal and vertical axes because of that. But even more often, the axes are referred to by variable-based names. The horizontal axis is called the x-axis, and the vertical axis is called the y-axis. Why use variable names? Well, there's two good reasons. The first is that variable names are more flexible than horizontal and vertical, which relate to specific orientations in space that may not always be relevant. And the second reason is that each of the two coordinate numbers is actually a variable that relates to a specific position along one of the two axes of the coordinate plane. And since those variables are usually called x and y, it makes sense to name the two axes the same way. The first coordinate number listed will be called x, and the second coordinate number listed will be called y. And we're always going to list the numbers in that same order, x first and then y, so that we never get confused about which is which. In fact, coordinates are often called ordered pairs because they're a pair of numbers that are always listed in the same order. X value first, y value second. So if you have the coordinates 3, 5, that means x equals 3 and y equals 5. Pretty easy, right? But now, how do we actually plot these coordinates, or ordered pairs, on the coordinate plane? Well, the first number in the ordered pair tells you where along the x-axis the point is located. And the second number in the ordered pair tells you where along the y-axis the point is located. The two numbers in an ordered pair work together to define a single point. And each one of the numbers only gives you half of the information about where that point is. To see how this works, let's plot the coordinates 3, 2. First, we locate the x value along the x-axis, which is at 3 in this case. But instead of putting a point there, we draw, or just imagine, a line perpendicular to the x-axis that goes through the 3. We do that because the first number in the ordered pair only tells us where along the x-axis the point is, but it could be anywhere along the y-axis. We won't know that until we plot the second number. So temporarily, we just draw a line there to represent every possible point that could have an x value of 3. Next, we locate the y value along the y-axis, which is at 2 in this case. But again, instead of putting a point there, we draw or just imagine a line perpendicular to the y-axis that goes through the 2. We do that because the second number in the ordered pair only tells us where along the y-axis the point is, but it could be anywhere along the x-axis. So we just draw a line there to represent every possible point that could have a y value of 2. But look what we've got now. The first line represents all the possible locations where x equals 3. And the second line represents all the possible locations where y equals 2. And the exact point where the two lines intersect represents the only point in the entire coordinate plane where both x equals 3 and y equals 2. That intersection is the location of our point. Pretty cool, huh? And that's a really good way to understand how the coordinate plane works. But I want to show you an even easier and more intuitive way to actually plot points. This more intuitive way involves starting with a point at the origin of the coordinate plane and then treating the coordinates like a set of simple instructions that tell you how far to move your point in the x and y directions. For example, to plot the coordinates 3, 2, like before, we start by imagining a point at the origin, 0, 0. Then we look at the first number in our ordered pair to see how far we need to move our point in the x direction. Since x is positive 3, we move our point a distance of 3 units in the positive x direction. And then from there, since y is positive 2, we move our point a distance of 2 units in the positive y direction. So that's a pretty easy method for plotting points. Let's try it a few more times so you get the idea. Let's plot the coordinates -4, 3. Again, we start by imagining a point at the origin and then let the coordinates tell us how far to move it along the x and y axes. Since x is -4, we move the point a distance of 4 units, but this time in the negative x direction, which is to the left. And then, since y is positive 3, we move the point a distance of 3 units in the positive y direction. Now let's plot the coordinates -3, -3. In this case, x and y are both negative, so starting with a point at 0, 0, we move it 3 units in the negative x direction and then 3 units in the negative y direction. And last, let's plot the coordinates 4, -2.5. Starting at 0, 0, we move the point 4 units in the positive x direction and then 2.5 units in the negative y direction. Okay, so we've plotted 4 ordered pairs the easy way. And did you notice that each of these points is located in a different region of the coordinate plane? These 4 regions are called quadrants, and their boundaries are defined by the 2 axes of the coordinate plane. The quadrants are named 1 through 4, so we can easily refer to them in conversations if we need to. Quadrant 1 is the upper right quadrant, and it contains all of the points where both the x and y values are positive. Quadrant 2 is the upper left, and it contains all of the points that have a negative x value and a positive y value. Quadrant 3 is the lower left, and it contains all of the points that have both a negative x and a negative y value. And quadrant 4 is the lower right, and it contains all of the points that have a positive x value and a negative y value. Roman numerals are usually used to label the 4 quadrants, and they're in that order because that's the order you would encounter the quadrants if you started with a line segment from the origin to the coordinate 1, 0, and then rotated that line counterclockwise around the origin. Doing this sweeps out a shape called a unit circle, which is divided into 4 quadrants, just like the coordinate plane. Alright, so now you know what the coordinate plane is, and you know how to plot points on it. But you might be wondering, what has this got to do with basic algebra? Well, algebra involves many different types of equations and functions that are a lot easier to understand if we graph their solutions on the coordinate plane. And as you know, the way to really get good at math is to practice what you've learned by doing some exercise problems. Thanks for watching Math Antics, and I'll see you next time.
Okay, now I would like for you guys to complete the Chapter 9 review, starting with this section, numbers 20 to 26 odds. And as you can see, I just want you to do the odds. So please start with 21, then do 23, then do number 25. Okay? Read the directions. It says use graph paper. Plot each pair of points on a coordinate plane. Connect the points to form a line segment and find its length. So you're going to plot the points on a coordinate plane. Then you're going to also make a line segment. And finally, you're going to find the length. Okay. So you should draw a coordinate plane that looks something like this. Okay. Make sure that there's a x-axis and a y-axis. Okay. And I want you to pause the video, take a couple minutes to plot it and figure out the answers for the odds in this section. And then when you're ready, you can move on to the next. You can press play again to see how I figured it out on my coordinate plane, to see if you guys did the same, or if you did something different but yet got the same answer, or maybe you did do something different and you got a different answer. And so just pause it right now and give it a go. Thanks. See you soon. All right, so by now you guys should have completed that section, numbers 21 through 25 odd, okay? And I'm gonna see how to do it. Okay, I'm gonna show you how I did it, okay, on here. So first, I don't know how well I can do this backwards, but I'll try. Okay, so number 21, A is -1. Okay, so this is my x-axis, -1, 0. And x coordinate always comes first. So here's -1. And then, oh, it's -1, 0. So it's right here. So then here, this is my A. And my B is 8, 0. Okay. So then 8 is on the x-axis, right? So 1, 2, 3, 4, So I don't think you guys could see very well. Okay, let's see. Okay, 8, 0 for B. 1, 2, 3, 4, 5, 6, 7, 8. So this is my B. Okay. And so for here, I see that, oh, it is, each of these increments are 1. Okay, so from here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is my, I'll just draw my line segment a little bit on top of the axis so you guys can see. So this is around 9 units long. Okay. All right, so that was for 21. I'm gonna do, let me see, I'm gonna do 23 in a different color. I'm gonna do it in pink. All right, so E is negative 6, 2. So negative 6, again, that's the x coordinate, right? So negative 6, I have to go this way on the x-axis because it's negative. So 1, 2, 3, 4, 5, 6. Negative 6, negative 2. So now negative 2 refers to the y coordinate. Okay, so I'm going to go down to be negative. So 1, 2. Okay, I hope that's right. Yeah, I think that's right. So then this one is E, which is negative 6, 2. Negative 6, negative 2. Now, I'm going to maybe put an E on the side here because I'm looking ahead at my F point, and my F point is negative 6, which is right here for x, and then negative 6, which is for y. So this is negative 2, negative 3, negative 4, negative 5, negative 6. So this is f. Then I have to draw my line segment, and then I know that each of these increments is 1, and I see that it is 1, 2, 3, 4. So then this is 4 units long. Okay. All right, and then the final one, number 25. Let me see what color I can use. Maybe I will use maybe I'll use a blue. Okay, so number 25. J is 0, negative 3. So 0 is at the origin, right? Negative 3, that's the y value. So I have to go down the y-axis 3 increments. 1, 2, 3. So here, so that's my J. Did I draw that J right? Okay, I did. All right, so that's my J. And then K is 0, negative 8. 0 again is at the origin. Negative 8 is on the y-axis. So 0, negative 8. So this is negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. This is negative 8. And again, I guess I'll draw a little bit to the side, my line. Oops. And what is my point? My point is K. I'm going to label it K. And let's see. Again, I know this is one increment for each square. So I'm going to count 1, 2, 3, 4, 5. So then this is 5 units. Maybe it's not going to fit, but there we go. Okay. And remember that when we measure distance or the length of a line segment, it cannot be negative, okay? All right, and then here is an example of the answer key from the book that might be better, more clear than what I wrote on my little board over here, okay? Okay, next, I would like for you guys, oh, thumbs up, good job for your effort. All right, next, I want you guys to do, oh, it's kind of covered up. I want you to do number 27 and 29. Okay, I know at the top it only says number 27, but please do number 27 and 29 after you look at the information that's given, okay, on the side over there. It says, the diagram shows the plan of a room. The side length of each grid square is 10 feet. Use the diagram to answer questions number 27 to 30. But again, we're only doing the odds. So I took a whole picture of the section in your book, but we're only doing the odds. So that's only 27 and 29. And I'm going to give you a couple minutes to just answer it on your own. do it on your own. If you have your book, look at your book. It's in your Chapter 9 review in the student book, starting with number 27. Okay? All right. So pause the video and I'll see you in a couple of minutes. Okay, so how was it? Was it hard? Was it easy? Was it so-so? Did it take you a while? Um, because it's hard to show you on the book, I just kind of drew my own on this little graph over here to the best that I could. Okay. And for me, I drew tick marks here. And one of these tick marks, which covers 2 squares, is 10. So what I'm going to do is 10 feet. So each of these 2 squares here is 10 feet. So one of these squares is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, which I hope it's correct. Yeah, okay. I drew it correctly. Okay, and all the way at the bottom, let's see, it goes to negative, right? Negative 10, negative 20, negative 30, and negative 40. Okay. All right, so it says the 8 corners of the room are labeled points A to H. Give the coordinates of each of these corners. All right, so I think I'm going to write the coordinate points in pink because I drew my square in pink, or the shape in pink. Okay, so with A, I remember for coordinate points, you have to do x comma y first, right? X coordinate goes first and then y coordinate is listed second. And we always need to put parentheses around our coordinate points, okay? Like this, okay? So x value is, let me see, I'm gonna follow my line down to the x, is here, which is 10, 20, 30, 40. So it's negative 40 because it's left to the origin, okay? And then my y value is positive because it's above the origin here along the y-axis. So let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, and then I'm gonna actually go across over here. And what I notice is H reflects A over the y-axis. You see that? It reflects it, okay? So I know if it reflects it, then, especially over the y-axis, okay, the y-coordinate is the same. But then the x-coordinate is actually not negative 40, but it's positive 40. But I'm going to just double check it on my number line because that's pretty easy to do. So let me go down and see, 10, 20, 30, 40. Yep, it is positive 40. Okay, all right. So now, let me see here. I think I'm going to go to B. Okay, my point B over here. You can't see me because there's a reflection. Okay, all right. So again, I have to figure out the x coordinate first. Okay, because it's written as x comma y, right? Okay, but here I'm just gonna write. Okay, so let's see. 10, 20, 30, 40. Is it positive 40 or negative 40? It's negative 40, right? Why? How do we know it's negative 40 and not positive 40? Yeah, it's left to the origin, or left of the origin. Okay, so it's negative 40. Also, we can kind of see over here, this point is directly, B is directly underneath A, so it's just negative 40. We didn't have to count, okay? Now here, I'm going to look at where the Y is. It's right here. So let's see, 10, 20. It's positive 20. And again, I notice G reflects B over which axis? Is it does G reflect B over the x-axis or the y-axis? It's the y-axis, okay? So that means, actually, the coordinate point for the y is 20. And again, just like what we did up here, it's not negative 40, it's positive 40. Okay, all right? And let's look here at the bottom, or not at the bottom, next to B. Okay, next to B I have C. Okay, I notice the y coordinate should be the same because C and B um, have the same y coordinate over here. Okay, so let's see, the y coordinate is 20. Okay, and then the C coordinate is, let's see, 10, 20. Is 20 more spaces to the left of B. So negative 40 plus negative 20 is negative 60. Okay. I know you guys probably can't see this very clearly, but soon I'm going to write the answers clearly for you on the next slide. Okay. So again, I notice C and F are a reflection of one another over the y-axis. Okay. So that means the y stays the same at 20, and then the x is not negative 60, it's positive 60. It's the opposite, okay? All right, so now let's go all the way down here to D, okay? Now D and C, it looks like, hey, they have the same x-axis, or the x point, x coordinate, okay? So what I'm going to do is I'm going to write the same x coordinate, which is negative 60, negative 60, and then the y coordinate, I have to count this, okay? So it's 10, 20, 30, 40, 40 feet below 0. So that's represented as negative 40, okay? And here, E is a reflection of D over the y-axis, okay? So that means, again, the y-coordinate is the same, which is negative 40, and E, the x-coordinate of E is the opposite of the x-coordinate of D, which is, what's the opposite of negative 60? It's positive 60, okay? So these are our 4 points, okay? And so that's the answer to number 27. And let's look at 29. I'm going to do that in a different color, in green, okay? It says Diana walks across the room from point B to G. So from point B to G, she walks across the room. So I'm going to mark it in green. Okay, oops, this looks kind of bad. Okay, so she goes from B to G and then walks from G to H. Where's my H? Here's my H. So I'm going to just kind of follow along the side here. Okay, from G to H. Okay, so first she walks from B to G, then she walks from G to H. I'm assuming following this path. Find the total distance in feet that Diana walks. Okay, so that means, hey, we just have to find the distance, the length of these two line segments, this line segment and that line segment, and we have to add it together, right? So from B to G, well, I notice, wait a minute, okay, it is negative 40 from here, and then it is positive 40 from here, okay? So this is 40 plus 40, which is, this is 80 feet over here, okay? So from G to H, I'm just gonna, well, I guess I can count it. Let's see. So it's 10, 20, 30, 40, that's 10, 20, 30, 40, 50, 60, 70, 80. Oh, look, this is also 80 feet, okay? But the question says, find the total distance in feet that Diana walks, okay? So the total distance is this line segment's length plus this line segment's length, which is 160. And what is the unit? We can't forget to write the unit, right? Feet. Okay, all right. Let's look at the next slide for a more clear view of the answers. Okay, so take a look at it, pause the video if you need to, compare your answers to the answers that are given here, and also what I did on my whiteboard over here. Okay, all right. we're gonna, I think, is that the last one? Give yourself a high five. If there's someone else with you in the room, give them a high five. Okay, I'm loving your grit to just push through this. Okay, all right. I think this is our last one. Okay. Um, so let's see. I thought I drew a graph, but I guess I didn't. On here, okay, it says that an athlete took part in a race. The distance the athlete ran, V meters, after T minutes, is given by V is equal to 300T. So V is equal to 300T. Okay. Oh, hey you guys. This looks like is this an inequality or an equation? It looks like an equation. I know it is because it has an equal sign in it, right? How many variables does this equation have? It has two variables, right? Okay, all right. If it has two variables, I know one is the dependent variable and then the other is the independent variable. And whenever we draw a coordinate plane, the x-axis represents the independent variable. Okay, so in this equation, which one is the independent variable and which one depends on the independent variable? I see that V depends on T. T could be whatever it wants, okay? But V will change according to whatever T is. So T is an independent variable, and we should plot T on the x-axis and plot V on the y-axis, okay? So I'm gonna pause the video and I'm gonna give you some time to graph the table, okay? I'm gonna graph it too because I actually didn't have time to graph it, so I guess you don't have to pause it. We can just do it together. I'm gonna just draw my graph. Okay. And then we want to label it V and T, right? Okay, so we're going to label the y-axis V because it is the dependent variable, and then the x-axis as T because it's the independent variable, okay? Okay, so I set up my graph like this, um, where I labeled my x-axis as T because it's the independent variable, and my y-axis as V because that's the dependent variable. Okay. And now I'm going to plot my points. Okay. So I have 0, 0, Okay, and I try to do it sideways or like this. Okay, so here's my 0, 0. I have 1, 300, 2, 600, 3 is 900, which I think is here. 4 is 1200 or 1200. And actually, I noticed, hey, wait a minute. This looks like what does this look like, you guys? What type of graph is this? It looks like it's a linear graph, right? Yeah, because it's a straight line when we connect all the points. All right, so that's the answer to A. It's a line graph or a linear graph. Now, let's look at question B, and I'm going to answer that in green. Okay, in green. It says, what is the distance the athlete ran in 3.5 minutes? So the good thing about this is what we could do is we can look at the time. Where is 3.5 minutes? Well, it's halfway between 3 and 4. So probably right here, okay? And you're gonna put it all the way up, okay? Here, and see where it meets the line. Then what you're gonna do is you're gonna go across like this, so then it hits the Y. So it looks like it'll be halfway between 900 and 1200, okay? Well, what is that? What's halfway between 900 and 1200? Well, what I can do is I can figure out how many units are in between 900 and 300, 900 and 1200, which is 300, okay? Then I can divide 300 by 2, which is equal to 150. So right here, okay, it is 150 meters, okay, when the distance the athlete ran was 3.5 minutes, okay? Oops, not 150 meters. It is 900 plus 150 meters, okay, which is equal to 1050 meters. Okay, so this is the answer to question B. And then C says, what is the average speed of the athlete? So how do we do this? How do we find the average speed? Do you remember? I'm kind of having a brain block moment. Speed, speed is a rate, right? And there's a formula that we learned about speed, okay, which is the rate is equal to distance times time. Let me see. So rate is equal to distance divided by time, actually. Yeah, okay. So the rate, which means speed, is equal to the distance divided by the time, okay? And so in here, I think the average speed is the total amount of minutes that this athlete ran is 4, right? And then the total distance traveled was 1,200, right? Okay, so what we're going to do is we're going to do 1,200 meters divided by 4 minutes. Okay? And this would equal 300 meters per minute. This is the average speed of the athlete. Okay. All right, let's look at D. Okay, and D, I'm going to do it in blue. Okay, it says, assuming the athlete runs at a constant speed, what is the distance she will run in 8 minutes? Okay, oh, all right. So let me see. What we could do is you can keep plotting the points until you reach 8 minutes. Okay, you can do that. Okay, and I think you know how to do that, right? Okay, so I'm gonna, if you want to do it that way, you can do it that way. Another way that you can do is we can look back at this formula, at this, equation over here. V is equal to 300 times T. T is the time, right? That'll give us the distance the athlete travels, okay? So I'm going to input in, oh, is this black? I want to use blue. Is this blue? Yeah, this one's blue. My colors got mixed up. No. Okay, so what is V when T is equal to T? Did we learn that a dot means multiply? I don't remember. I can just put an X for multiply. T is 8 times 8. Okay, so that's not a variable. It's a multiplication sign. Okay, then this is equal to 2,400 meters. Okay, all right. Okay, now E. Name the dependent and independent variables. Oh, you know this. We talked about this, didn't we? Okay, so from another color, I'll do bright green. Okay, you know that the dependent variable is the y-axis. Okay, so the dependent variable is v, and then the independent variable is the x-axis, which is t. Okay. All right. So let's see here. Here's the clearer answer. Okay. And good job. All right. Well, that's all for today. Bye.